All right, I want to talk about the Radiant Snowman. This is a Radiant Snowman. It's a unit circle with another circle on top of it. Before we get into the details of the Radiant Snowman, I want to remind us of this problem, that if the point 2 root 3 is on a terminal side of theta, can we find the sine, cosine, and tangent of theta? Now, the first thing we did was to plot that point. 2 root 3 is about right here. And then that would mean that our angle, since it's a position angle, has to have the initial side on the positive x-axis, and then the terminal side is going to run through that point. That means our angle is going to be down here. And it also means we have this right triangle that we can look at. Because 2 root 3 is a point that's on that terminal side, the way we have it drawn, our base is 2, and then the height would be 2 square root 3. We can use that, since it's a right triangle, to come up with the radius of the circle, or that hypotenuse of the triangle. And from the Pythagorean theorem, we know that the radius is going to be the square root of 2 squared plus 2 root 3 squared. So real quickly, 2 squared is 4, 2 root 3 squared is 12. So we're looking at the square root of 16, which is 4. Now we can just look at our triangle to find the sine, cosine, and tangent of theta. So first of all, the sine of theta is the opposite over the hypotenuse, 2 root 3 over 4. And we simplify that down to square root of 3 over 2. For the cosine of theta, that's going to be the adjacent over the hypotenuse, which simplifies to a half. And finally, the tangent of theta is opposite over adjacent, which is square root of 3. Ultimately, what came out of that problem was a nice little result. That if we were to generalize this and talk about any point that's on the terminal side of a position angle, then that base is going to be x, this height is going to be y, and the hypotenuse will always be the radius. Then sine is opposite over hypotenuse, or y over the radius. Cosine is the base over the radius. And tangent is going to be y over x. A nice little result here. But what if that ordered pair xy is on the unit circle? Now, a unit circle is a special kind of circle. A unit circle is one where the radius is 1. The unit circle has a radius of 1, but it's also centered at the origin. So if xy is on a unit circle, then that means when we draw our triangle, our base is x, our height is y, but the radius is always going to be 1. That helps us out tremendously because we know that sine is the opposite over the hypotenuse, y over 1. That's going to simplify to y. And the cosine is the base over the hypotenuse. That'll be x. This is fantastic because what it tells us is that any ordered pair that is on the unit circle could be written as cosine, sine. So the x-coordinate is always the cosine, and the y-coordinate is always the sine. Furthermore, when we're talking about tangent, the tangent is opposite over adjacent. That gives us a nice result as well, that the tangent is going to be the y-coordinate, sine, divided by the x-coordinate, cosine. When it comes to things that you can write down on your Radiant Snowman, you can write down the things that are in these two boxes. Speaking of the Radiant Snowman, this is it. Snowman has a unit circle for a body, and then there's this extra circle on top. The extra circle is really just to make a hat out of it, put some eyes on there, maybe a nose, a little smiley face, and just make it look like a snowman. It really has nothing to do with what we're about to do. It's the body that's most important to us. And in fact, I want to look at, in particular, this quadrant of the Radiant Snowman. Now remember, Radiant Snowman is a unit circle. So anywhere we go on a Radiant Snowman, the radius is going to be 1. You'll also notice in this first quadrant, there's 3 big points on the edge of the circle. The first one I want to look at is this one that's in the middle. All 3 of these points are going to be important to us. This first one, it's important because if we were to have that point on the terminal side of a position angle, that point represents 45 degrees. So the old 45, 45, 90 triangle. So we'll have our 2 legs of our triangle be the same. And what we know about this, the only other thing we know about this triangle is the length of the hypotenuse. Because we're talking about a unit circle, the radius is always 1. So the hypotenuse of this triangle is always going to be 1. Now there's a couple things that we already know about 45, 45, 90 triangle. And that is that both of the sides are the same length. And if the sides were both 1, then the hypotenuse is going to be square root of 2. However, we're trying to work backwards and figure out what these side lengths are when we know that the hypotenuse is 1. So instead of multiplying by square root of 2 to find the hypotenuse, we're going to work backwards, and we take that 1 and divide it by square root of 2. So both of these lengths are 1 over square root of 2, which we should rationalize the denominator on them and get square root of 2 over 2. Since the base of this triangle represents the x-coordinate, that's going to be square root of 2 over 2. And the height of this triangle is going to represent the y-coordinate, so that would be square root of 2 over 2 as well. The nice part about the Radiant Snowman is now that I have this ordered pair, we can identify what the sine of 45 degrees is. We can take a look at the cosine, because we already found out that at every point on the unit circle, the x-coordinate is the cosine. And the y-coordinate is the sine. And we could also find the tangent of 45 degrees because tangent is sine over cosine. So we're going to take square root of 2 over 2 over square root of 2 over 2. Everything's going to cancel, and so that tangent is going to equal 1. There's one more thing that I want to point out, and that is that the Radiant Snowman is called a Radiant Snowman for a reason. This angle, this 45, how this point represents 45 degrees, we want to identify what that is in radians. And we can convert that real quickly. Remember, put it as a fraction, multiply by our unit multiplier. We're going to want 180 degrees in the denominator, and pi in the numerator. That gets degrees to cancel. And we'll have 45 pi over 180. You can simplify that to be pi over 4. So now we're going to take some time and go through each of the remaining points that are in this first quadrant. This lower point, that we signal that one out because if we were to have our right triangle here, this would represent the 30-degree angle. And we already know about a 30, 60, 90 triangle, that if we have our 30-degree angle down in this corner here, 30 degrees, and the short side is 1, then the hypotenuse is going to be twice as big, and the longer side is square root of 3 times as big as that shorter side. But in the triangle we have, this point is on the unit circle, so it's the hypotenuse that is 1. Working backwards to that shorter side, that means we'd have to divide by 2. And then to go from the short side to the longer side, again, we multiply that 1/2 by the square root of 3. So square root of 3 over 2. So our ordered pair is square root of 3 over 2 and 1/2. So we can go ahead and identify the sine, cosine, and tangent when it comes to sine of 30 and cosine of 30. With both of these, remember, any ordered pair xy is going to be cosine sine. So the cosine of 30 degrees is going to be the x-coordinate, square root of 3 over 2. And the sine of 30 degrees is going to be the y-coordinate, 1/2. for tangent of 30 degrees, we have to do sine over cosine. So 1/2 over square root 3 over 2. Dividing by a fraction is the same as multiplying by the reciprocal. So 2 over the square root of 3. These will cancel. We'll have square root of 3 in the denominator. We should rationalize the denominator by multiplying by square root of 3 over 3. And that ends up being our tangent. The one last thing, of course, again, is going to be taking the degrees, turning them to radians. This represents our 30 degrees. And to convert that, we're going to multiply by pi over 180 degrees. The degrees on both of these will cancel. And simplify the fraction, 30 divided by 180. That'll give us pi over 6 as the radian measure for 30 degrees. On the other side of the 45-degree angle is this important point. Important because it's the 60 degrees of our 30, 60, 90 triangle. That means that when our hypotenuse is 1, our short side is now on the bottom, and our longer side is going to be the height. So this switches the x and the y coordinates around, and now 1/2 is the x coordinate. Square root of 3 over 2 is the y coordinate. So when we're going to try and find the sine, cosine, and tangent, remember, cosine of 60 degrees is going to be the x-coordinate, 1/2, and sine of 60 degrees is going to be the y-coordinate there, the square root of 3 over 2. If we want to find the tangent, tangent of 60 is going to be sine over cosine. So now we got the square root of 3 over 2 over 1/2. Again, these over 2's, they're going to cancel, and we're left with square root of 3 over 1, which is just square root of 3. Last thing to do is to convert that 60 degrees, and 60 degrees multiplied by pi over 180. Degrees cancel. Simplify the fraction, we get 60 degrees to be pi over 3. For the last 2 points that make up the first quadrant of your Radiant Snowman, it's very hard to see the triangle right away. But you need to kind of see it move into position. What a lot of people do as soon as the point becomes right on an axis is they draw a triangle from one corner of the circle to the other corner. And that's not how these triangles are supposed to be. Think about how our triangles move from 30 degrees to 45 degrees to 60 degrees, maybe 80 degrees, 85 degrees. We see that the right angle is always on the base of on the x-axis. And as we move this point closer to being on a 90-degree angle, that base gets smaller and smaller and smaller. So really what we can think about when we're looking at our triangle here is that it is a very skinny triangle with its right angle over here. The thing about this very, very skinny triangle is that its hypotenuse is 1, and so is its longest leg. And the base has actually become so small that it's 0. Which you realize is not a real, actual triangle, of course. And so you try to make one that looks like a triangle you expect. But don't worry about the triangle part. Remember that this point is a point on the unit circle. It's got an x-coordinate, it's got a y-coordinate. Since it's on the y-axis, its x-coordinate is 0. And it's 1 unit away from the origin, so its y-coordinate is 1. Now we got everything we need to find the sine, cosine, and tangent of this position angle, this 90-degree angle. When it comes to sine of 90 degrees, it's going to be the y-coordinate, 1. Cosine, it's going to be the x-coordinate, 0. And when it comes to tangent, tangent of 90 degrees is going to be sine over cosine. 1 divided by 0 is undefined. Last thing we got to do, of course, is to convert. And so we're going to convert 90 degrees into radians. So we'll multiply by pi over 180. And we'll get this 90-degree angle down here. The right angle in the corner is going to be equal to pi over 2. The last important point in the first quadrant is down here. We recognize that this ordered pair has an x-coordinate 1 and y-coordinate 0. The angle that it's talking about, its position angle here, is going to be where the terminal side is right on top of the initial side. So if we think about that terminal side not rotating around the circle at all, that would be 0 degrees. If we can think about that angle is rotating the entire way around, it's 360 degrees. We already know that for both of these, we know their radian measure. 0 degrees, obviously 0 radians. But 360 degrees, one entire trip around the circle, is 2 pi radians. So what are the sine, cosine, and tangent? When it comes to the sine of 0 degrees, that's the y-coordinate 0. The cosine of 360 degrees, that's going to be the x-coordinate 1. And if we want to look at the tangent of 0, 360, or 2 pi, that's going to be sine over cosine, which is not undefined now. Now 0 divided by 1 is 0. So now, what are all the things that you can write on your Radiant Snowman? Everything that you see here. You can have that the ordered pair, x, y, for any of these points is going to be cosine, sine. The tangent for any of the angles is going to be the sine over cosine. And you can have every ordered pair around the first quadrant of our unit circle. You can have all of those important angle measures identified, as well as being in degrees and radians. So pause this, make sure you got your Radiant Snowman right.